All right. Thank you, everyone, for joining us today for another partner webinar. This one is very special. We are very fortunate to have Eugene Mandel. I hope I emphasized that correctly. Head of product at Superconductive, the makers of Great Expectations, which you may be familiar with. If you're not, you should be familiar with it, and you are about to be familiar with it. Couple of housekeeping items to kick off before I kick it to Eugene. First of all, to submit questions over the course of this webinar, which will be read out at the end during a Q&A portion with Eugene, please do join our Label Studio community Slack. There's a bit.ly at the bottom of your screen here, and I'll make sure that that comes up on all these screens that I share. So today's agenda, first of all, a couple of self-serving housekeeping items. Thank you for letting me get those in, Eugene. And then we will kick it to Eugene to talk a little bit about Great Expectations and testing your data with Label Studio. And then we'll have Q&A towards the end. Again, there's the bit.ly, or you can just look in the live stream chat on YouTube, and it's got a link to our to join our Slack as well. And then we'll wrap it up. That's just a picture of our Slack. So housekeeping items. Again, join our Slack community if you haven't already to submit questions. I really would like some questions. I even submitted my own dummy question, Eugene. Dummy question, just to kind of get the ball rolling so no one feels nervous that they're going to ask the dumb question. I already did. And then a brief announcement now, and we'll talk about this more later. We're going to be doing a monthly newsletter starting next week. A Label Studio monthly newsletter that is essentially just a very succinct compilation of the latest blogs, tutorials, webinars, release info, and featured community content in one place, delivered to your inbox once a month. If you want to subscribe to that, join our Substack. It's labelstudio.substack.com. Again, the first newsletter will be out Wednesday, June 30th. That's next week. And yeah, we're excited to get this going. So the next webinar we're going to do is another community conversation. The last one was really fascinating. Law and Justice Initiative in Indian municipal courts. The next one, we're finalizing who it's going to be with from the community, but it will be hopefully another inspiring and interesting use case and usage of the platform. And then we have a new blog out, a listicle. We're doing some listicles now. This one, if you're interested in or considering doing NLP labeling, natural language processing labeling, there are 10 best practices or important considerations that Sarah Moir from our team, who's head of documentation, and Nikolai Lyubimov, who is our CTO, put together. That is available here. You can also check our announcements channel in the Label Studio Slack community, and it'll also be in the newsletter. All right, that's it for self-promotion. Let's kick it to Eugene. Without further ado, I'm going to stop presenting, and if you wanted to turn on your camera, Eugene, I will let you drive.
Hi, Michael. Thank you. I mean, that's really fun. So let me share my screen. I have some slides here. 1 second. All right, let me know if you see it.
I see it.
Excellent. All right, so couple of words about myself. So I'm Eugene Mandel, head of product for Superconductive, the company behind Great Expectations. We'll talk about Great Expectations in a second. Just tiny bit of background because I think it's relevant. So I've been involved in startups for pretty long time, and the connecting thread was always working with data. And from everything I've seen, my conclusion was that better data tends to beat better algorithms. Before Superconductive, the previous company I worked for, we were training bots for customer support that would answer frequently asked questions, while the algorithms were pretty much off the shelf. Most of our work was building a pipeline for labeling for active learning with a human-in-the-loop component, right? Which is why I'm really happy to be in this webinar, because seeing a product that helps doing this, I mean, makes me very, very happy. So, and of course, if we're saying that better data and better label data tends to beat better algorithms, well, data quality is definitely an issue. So let's start with what Great Expectations is. So it's an open source project. Well, it's obviously on GitHub. It was launched in 2018 by two original authors, Abe Gong and James Campbell, who are now CEO and CTO of Superconductive, the company kind of that is popularizing Great Expectations and pushing it forward. As of now, it's the most popular open source library for data pipeline testing. As you see, I mean, we have over 4,500 stars on GitHub, very active contributor community, and I'll talk a bit about why it's important. And we have a really good community on Slack and on GitHub, which you are very much invited to join, and I'll have links later. So what problem Great Expectations solves? So, all right. So data quality has two sources of problems. One I call pipeline risks, and the other one I call data risks. Let's talk about pipeline risks first, right? So as you, like in the previous company, we had like this whole spaghetti-like pipeline for training. Any company that deals with data ends up with a pretty complicated kind of like what you see on the left, graph of dependencies of like, job computes a data set, somebody else downstream depends on this data set, the pipeline runs with some frequency, there are some kind of triggers, and because it's a software artifact, of course there are problems, right? So one problem can be just an outage. And actually, I want to kind of, and the other source is data risk. So I want to, now data risk, it means that the pipeline is fine, but the data itself might be bad or misunderstood. Just to talk a bit about a couple of examples of problems. So drift, right? So let's say you're getting, I don't know, daily batches of data, and there is some kind of numeric quantity there, I don't know, price of some, average price of something, right? As you progress, that value might change, right? So the value drifts, and if specifically you have a, let's say, machine learning model that was trained once, not retrained, but the value that it was, one of the variables is changing, of course, the predictions that are coming out of this model will be less and less relevant over time, right? Now, this is an example of a data quality problem where you cannot say that data is bad. It's more like you misunderstood the data, and that's why you are not using it right, and the result is bad. Outliers. So my favorite example is anybody who's done any data science course used the sample data set of real estate prices with the task of predicting real estate prices. And probably there is a dimension of number of bedrooms, number of square feet, number of bathrooms. And then from this, you can predict the price of house, right? So every time you see a mansion like that with, I don't know, tens of bathrooms and bedrooms, if it's included in the training set, it's an outlier and it's probably going to be skewing the model, right? So again, this is another example of having this mention in the data set is not necessarily bad. But if you do have it, you need to understand it. Do I have to count it? Do I have to discount it? So it's not data being good or bad. It's more, is a particular data fit for a particular purpose? And just last example of data quality problem. This is an example of a pipeline risk, not the data risk itself. Outage. So let's say you have some kind of hourly process that kicks out a log file, right? And at some point, this process dies. And from the point of view of people downstream that look at those log files, there are maybe 6 hours or 8 hours when there's no data, right? So if you're not careful, you can just assume that, well, nothing happened, nothing bad or nothing good, right? But you have to be aware that, well, those files were not even generated, and you have to make sure not to train anything on this data or somehow fill it in intelligently. All right, so how Great Expectations solves those problems? So the basic unit of Great Expectations is an expectation. What is an expectation? An expectation is a statement that describes some kind of quantity about the data that can be expressed both in the code and it can be expressed in natural language. I'm showing here an example of, okay, actually, let's look down first, right? So just in plain English, we're saying that I expect values in this column to be between 1 and 6. Well, great, it's easy to communicate to somebody, right? I mean, I just expect this in my column. So if you look up, we have an expectation in the library, expect column values to be between. And then this expectation takes as an argument column name and min value and max value. The expectation is stored as JSON. And of course, if it's so, it can be code, it can be configuration, and it can be natural language. Those three modes allow something very interesting. Expectations is a very good way to communicate, to talk about data quality or data in general between human and human, human and machine, and machine and machine. And why is it important? Because sometimes we talk about data testing, but the real problem of data quality is much broader. If you're a data engineer, more and more you are working with people across your organization that are not necessarily coders. So just implementing data tests in Python, in Java, or in SQL is not enough, because when they fail, you have to communicate to your collaborators. All right, next. So once you created an expectation, you save this configuration. If you get a batch of data, you can validate or evaluate an expectation against a particular batch of data. And then, so basically, this expectation goes in against the batch, and what goes out is a validation result. A batch of data can either satisfy this expectation or it can violate it. If it violates it, you will see examples of why it doesn't meet the expectation. So it creates a very structured and rich language to talk about data quality in terms of expectations. So what can you express with an expectation? Now, this is one of my favorite things, because Great Expectations is a library, but it is also an emerging open source standard for talking about data quality, and standard in terms of language. It's kind of, let's create a dictionary. What can be said about data between machines and humans? So here is a sample of expectations that already exist in the library. Expect column to exist. No explanation needed, right? Expect table row count to be between X and Y. Expect column values to be unique in a particular column. Or you can take another column and say expect column values to not be null. Or you can say that I expect no more than 5% empty values. Other things that you can expect from values in a column, for example, what's the range? Expect column values to be between. You can demand that, or expect that all values match some regular expression. You also can think about aggregate metrics or aggregate statistics in a column. Let's say if you have a numerical column, you can compute its mean, and you can expect its mean to be between some kind of X and Y. And you can have even more sophisticated expectations where you reason about a distribution of values. So for example, there is an expect column KL divergence to be less than something. You can define that the distribution of values in this column looks like that. Basically, you can kind of draw a bar chart and then say, I expect my real distribution to be more or less like that, and more or less is expressed as KL divergence with a threshold. So as you see, you can take fairly sophisticated logic and put it under an expectation, especially when you talk about sophisticated checks. Of course, any data engineer could implement their own test, but why? It's much better if we implement it once. It's tested. We have a short name, a relatively short name for this, and now you can use it. All expectations so far that you've seen were kind of generic. But where it becomes very, very, oh, sorry, when it becomes very exciting, I'm sorry, what was going on here? Okay, yeah. Where it becomes really exciting is that other people, contributors, can implement additional expectations, and they can express their own domain knowledge using expectations. Imagine somebody writing an expectation, expect column values to be a valid bank routing number, or a valid FDA drug code, or a valid room temperature reading. So this way, the community keeps enriching the vocabulary and the knowledge that can be expressed in expectations. This is one of the reasons why a number of contributors, and in general, the contributor community, is extremely important for us. A good example is that there are so many different domains of data. The core team obviously cannot be expert in all of them. So when a sub community of data people that deals with I know, geographic data comes up with expectations specific for all the geo, it's amazing because they're just, they're doing something that we would not be able to do, and they're expanding the language. All right, so where expectations come from? So when you say I expect something from my data, where does this knowledge come from? There are two sources. One is what you see, domain expertise. So I had this example of expect column values to be a valid temperature reading. So you can just say, well, okay, if I get temperature reading of 10,000, that's probably unreasonable. Minus 10,000, unreasonable as well. And then you decide if you are in Celsius or in Fahrenheit, and you just express your domain knowledge to create min and max for those values. Also, expectations can come from data profiling. Imagine that you are getting a new data set you have not worked with, but you have, I know, 100 or 1,000 batches. Let's say you have hourly log files, right? If you have 1,000 hourly log files, you can analyze those log files and see how which constraints would capture the characteristics of this data. Great Expectations has a kind of API and actual implementations of profilers. Profilers are pieces of software that take one or more samples of data of the same data set, and then they spit out initial expectations. Usually those expectations need to be edited, and that's why domain expertise and data profiling work so well together. And of course, after that, you validate, you create expectations, you validate your data, and then you get success or failure on every page that you validate. So we said that Great Expectations allows humans to talk to humans, humans to talk to machines, and machines to talk to machines. So in order to translate it to machine language, we have to think about different execution engines that people use for different compute environments that people use to manipulate data. So currently, every expectation that we have in the library is compiled, so to speak, into pandas, into Spark, and into SQL Alchemy. Of course, SQL Alchemy allows us to talk to a multitude of databases that are used in the by data engineers and data analysts. So that's another beauty, is that once you implement a new expectation, once you can use it on multiple compute engines. All right. So when you validate a particular batch of data against an expectation, or against what we call a suite of expectations, we call it suite just very similarly to test suite. Expectation suite is a collection of expectations that describe your expectations of a particular data set. When validation result is created after validating a batch against a suite, Great Expectations compiles it or renders it into HTML. This is called data docs, and this is one of the features that the community loves the best about Great Expectations, because this creates a visual representation. For example, remember we had this expectation values must always be between 1 and 6, And after validating a particular batch against this expectation, data docs show, well, 1,579 unexpected values found. So it provides some context for what the failure was. Now, if you collaborate with other people, imagine just sharing this HTML with your collaborators upstream, downstream, or your colleagues. It's much easier to explain, it's much easier to show what was wrong. Actually, from personal experience, sometime before that, when there was a data problem, I remember very long email threads, people trying to explain to each other just in words how the data is wrong. This is much neater solution. Another value of data docs, and this is all this has became pretty much a mantra for us on the team, that your tests are your docs and your docs are your tests. What does it mean? So a lot of data teams want to have data documentation. Creating data documentation is a work that everybody wants the work product, but not everybody wants to do the work, right? Because it's just kind of yet another chore that you want to do. So when you create tests in the form of expectations, those tests can be compiled immediately into HTML, producing data docs. And this way, data documentation becomes a side effect, an exhaust of an activity that you definitely want to do, creating tests. This way, your documentation will never go stale, and creating it will not be a separate project. Right, so I very much emphasize the value of Great Expectations for its language and its open standard. But when you get Great Expectations, most of the code, or at least half of the code, is not just the expectations themselves. When you want to deploy Great Expectations in a particular pipeline, on a particular data set, there are so many things to think about, right? You have to think about how to configure everything, how to connect to the data, where to store the expectations themselves, where to store configuration, where to store validation results, how to implement the logic of validation. So the library comes with all of those questions answered. So essentially, you have to think about kind of two layers of Great Expectations. One is the language of expectations themselves, and the second one, the machinery that helps you apply this language. All right, so now that we talked about what Great Expectations is, how can I get started? So first of all, we are on GitHub, Great Expectations, very easy to find, and here's this link. We have documentation that we are actually in the process of improving, but please go here, and it has tutorials, it has guides, it has explanation how to use Great Expectations in different pipelines with different databases and different formats of data. And we have a very active Slack community on greatexpectations.io/Slack, which we invite you to join. People use it to talk about data quality, to ask questions, to help each other. Yeah, and last thing that I wanted to show is just a very short example of what it looks like when you edit the expectations. So in the open source, I won't show the whole flow, but think about this. So this is a data. So this is a data set. It's a public data set from New York cabs. You see like pickup daytime, drop-off daytime, how many passengers, what was the distance of the trip, and so forth, right? So we use this data set as an example in our tutorial. And I want to show expectations that were created about this data set and how to manipulate. Jupyter Notebook is how you manipulate that and how you create and edit expectations. And I just want to show you. So for example, yes, so remember how we talked about this expectation, expect column minimum, for example, to be between something and something, right? So there was a column passenger count. You just do this, and you can, if you evaluate this line, it will give you the validation result. Now, the validation result in this case says, first of all, success true, which means that the sample batch of the data set met my expectations. However, if, let's just say max value, I don't know, -1 and mean value -2, reevaluate it. Now it should say success false, and it says, well, the actual observed value is 1. So this is just an example of how to manipulate those expectations. After that, you just save it into a sweep, compile into HTML, and you can use this sweep to validate your data. All right, I think so far that's what I have. So I'm very much welcoming any questions about it. Oh, sorry.
Thank you. I submitted my own dummy questions here while people hopefully submit theirs over on our webinars Slack channel, and I'm going to throw that up really quickly again. Thank you. That was really, really fascinating. Side note, our head of documentation loves the emphasis on documentation. What do you know? That's amazing. Shout out to Sarah. All right, let me share my screen really quickly. And again, thanks for your time. Eugene is extremely busy, but he made time in the middle of a business trip to do this. So thanks again. All right, just flash this up while I read off. Actually, I kind of can't. Isn't that right? All right, I'm just going to do this. So first question, and I'm trying to ask a very dumb, simple question to make it so that others feel more comfortable. Like, well, at least it's not that bad. My question. So it sounds like you answered this over the course of the webinar. Sounds like Jupyter notebooks are the way to manipulate your expectations, correct? There's no sort of alternative method.
Okay, so great. So it's a great question. This is the current UI UX because the original users of Great Expectations, kind of data engineers, data analysts, and data scientists are okay with code. I should be very clear that to use Great Expectations right now, you should be okay with using basic Python, not writing a Python program, but just syntax. You have to be okay to configure stuff using YML, and you have to be comfortable enough using Jupyter Notebook. However, we see something very interesting. Great Expectations is frequently adopted by a data team, and then it starts propagating it inside the organization to people who are not coders. They're product managers, program managers, domain experts on different data sets. And seeing that this is a kind of a real push, we actually are working on a SaaS product that will allow people who are not coders in their daily life to have well, among other things, it will allow them to have a better UI and better collaboration.
Clickable front-end interface kind of deal.
Clickable front-end, permissions, collaboration. Yeah, actually, if you join Slack, we will be doing sessions on the upcoming SaaS product, kind of getting feedback. We very much want a lot of feedback from the community, so we build something that is right. So join Slack, and from there, yeah.
You had a community roadmap meeting yesterday, right?
Yesterday, yeah. Unfortunately, I was not there. I was traveling, but yeah.
That's awesome. I'm going to consider stealing that as an idea. That's really great. Another question I have, and then thank you, Nikolai, our CTO. He submitted a question. I'll get to that next. So with respect to the domain expertise-based profiles, I guess I'm wondering about drift, or I mean, is there a risk with something like, let's say, dynamic, like gas prices, of the sort of the trust in the, like, it seems like there's an obfuscation layer below which people just input data, and it may or may not continue to be relevant. There may be some ground truth drift. Is that the case, or am I missing something? I'm probably missing something.
No, I think that's exactly the point. Yeah. So any kind of well, gas price is great. Yeah, it's a great example, right? So how would you say, like in natural language, what do you expect from that numeric quantity, right? You probably would say that, well, I definitely has to be positive. Yeah. I would be very surprised if it was $100 a gallon, but never say never. Right. And you would probably start encoding some kind of drift. Like you would expect drift, you would expect it to go up and down, right? So the nice thing is that you don't have to use only the expectations that are currently in the library. You can literally implement and contribute an expectation that somehow, I can't think right now about the exact interface, that encodes the idea of drift. So the drift becomes not an exception, it actually becomes the rule, right? Because behind a simple Boolean expectation, you can put code as complicated as you can put a whole machine learning model. That it's as long as it spits out a Boolean true or false, why not?
Yeah, wow, that blows my mind. That's amazing. All right, so from our CTO, Nikolai, it would be interesting to know about some use cases where we need to validate machine learning output models with GE, validation monitoring phase, rather than initial training data. There's a question in there. It's not necessarily formed as a question, but does that make sense?
Yeah, absolutely. Yeah, we have users who are exactly kind of adopted GE for this use case, right? So let's say, so forget training, right? Let's say you have kind of, online, like machine learning deployed online. Let's say it gets a batch, and batch of data spits out some prediction, right? So you can validate. You actually can validate two things that I see like in our community. You can validate the input itself, right? Because what if the data that goes into prediction is not what you expect, right? And not what you expect, it's my example with this mention, right? It's very, so from experience, it's difficult to build a model that knows to say, I don't know. Unfortunately, machine learning models are very happy to always give you an answer. It's like in a person that would be a really unwelcome quality, and a very unwelcome quality. Well, in machine learning model as well. So an expectation can provide you a way to say, I don't know. If you get a mention, but you know that you were trained on normal houses, instead of sending it to prediction, you would say, oops, no, sorry, right? So you can validate the input, and you can also validate the prediction, the output, because if it predicted, if in our real estate example, it predicted that the price is minus 10 million, an expectation would immediately say, no, it's not.
Yeah, that makes sense. I was thinking, I went down a rabbit hole in my head when you said it would be a very bad quality in people if they just never admitted that they didn't know. And so many social commentaries I could make right now that I will not, but you can, I'm sure everyone's aware. Anyway, Eugene, I think that's it for questions. Did you have anything else you wanted to plug or share? It's been wonderful having you present this, and thank you for your time as well.
No, again, like I think the use cases of training and data quality are very much kind of complementary. So I just invite people to check it out, join Slack, and we want to grow the community.
They have an awesome Slack community. I know their community manager, Kyle. They're great. Definitely join the Great Expectations Slack if you're in our Slack and you're not in theirs, and vice versa. All right, thank you very much. Had to slip that in. Thank you very much, Eugene, for your time. I'm just going to throw up a last screen with a little bit of info. Yeah, that's it. Thanks a bunch, and have a great rest of your day. Thank you.
Thank you. It's been fun. Thanks.